Question 1, part E, asked to write down the line of regression equation. And we have done all of the hard work for this part again, back in part B. And we have actually already performed the stat calculation in part D. So if you're not sure how we got these values here that I'm clicking on, so in columns G and H of my calculator here, I recommend going back and maybe watching part B and then part D, because we have the values M and B. And for a line of regression equation, it's in the form y equals mx plus, now sometimes see this as b and sometimes see this as c, doesn't really matter, it's just a constant at the end. The calculator gives it as b, where m is the gradient and b is the y-intercept. And you might be wondering, what exactly does this even mean? Well, what the line of regression equation is the line of best fit, that if I was to draw a straight line on top of all of these data points, it would be as close to going on top of all of them as possible. So that's what this line of regression equation means. And this R value here, the closer to 1 it is how strongly this line of best fit represents the data point. So if the dots are very close to the line, this R value will be close to 1. But I think we're going to get to that in a later question. But in this question, we're just writing down in the line of a regression equation, our M value is, let's find it, minus 0.761. And our B value is 46 point, okay, to 3 significant figures, this will actually be 47.0 because the 9 is rounded up by the 7, so 47.0. So therefore, our line of regression equation is minus 0.761 plus 47.0. And that is the answer to part E, question 1.